Hello everyone, my name is Rakesh and welcome back to Zero to Cloud. So, have you ever wondered how Google services like YouTube or Google search engine handles millions of users at the same time and yet they never crash? The secret lies in something called load balancing, and in this video, we will uncover how Google Cloud uses it to make sure your application runs smoothly even during traffic spike. So here's what we will cover today. First, we will understand why do we need load balancing, then what exactly is load balancing, how does load balancer work behind the scene, and what type of load balancer does Google Cloud offer. And by the end of the session, you will not only understand it, you will be able to set it up yourself in the hands-on lab. So now let's understand why we need, why cloud load balancing. So let's start with a simple question. What happens when too many people try to use your app at once? Imagine you run a small website on one virtual machine. When traffic is low, everything is fine. But as soon as thousands of users logs in together, that simple server start to struggle. Page loads slowly and eventually it crashes. So say in this diagram, so without load balancing, what happens? So here you can see there are multiple users trying to connect to a server. So without load balancer, what happens? So a request 1 will go to server 1. Request 2 is also going to server 2, server 1. Request 3 is also going to server 1. Request 4 is also going to server 1. And as you can see, other servers are free, but there is no traffic which is redirecting to that server. And all the traffic is going to server 1. That makes it server 2 be overloaded of traffic. So without load balancing, user faces such issues. So what is cloud load balancer is? So first we'll try to understand what cloud load balancer is. So in simple terms, a cloud load balancer acts like a smart traffic controller of your app. It decides which backend server should handle users' request based on factors like location, response time, and server health. And the best part, it's fully managed by Google. You don't have to maintain hardware, monitor server manually, or worry about failover. Google's global infrastructure take care of it, the same one that runs YouTube and Gmail. So in this diagram, I'll understand how what is cloud load balancer is. So here you can see that there are multiple users trying to request to a website. So what load balancer does? So as soon as user searching particular site, let's say you're trying to access flipkart.com. So let's say flipkart.com is the website. So while accessing that server, so these are the server for flipkart.com, but before that server there is a load balancer which is used to transfer the traffic. So what it will does, let's say user is trying to access the flipkart.com. So what load balancer will does, based on some factors such as location, so it will decide that traffic will go to which server. Let's say a traffic is coming from India and server 1 is situated in India. So what load balancer will do, it will transfer that traffic to server 1. Similarly, if server 2 is in some other region of US and someone from US is trying to reach out to Flipkart.com, then load balancer will route the traffic to server 2. So load balancer will decide based on different factors such as response time, server health, and location. It will route the traffic. So now let's understand how does load balancer actually works it behind the scene. So how it works? So when user tries to access your website, the request first reaches to Google Cloud Load Balancer, not directly to your server. The load balancer checks which backend server is healthy and closest to user. Then it forwards the traffic there automatically. Let's say if one server goes down, the load balancer instantly redirects traffic to another healthy one. No manual intervention required. Think of it like a restaurant host who sits new guest at next available table, ensuring no one has to wait too long and no table gets overloaded. Let's try to understand with this diagram. So as user is trying to reach out to any website or any server, so in that case, what happens? First, load balancer will check which location the traffic is coming from, or there are different factors also available. Based on that, it will redirect the traffic to, let's say, web server 1, web server 2, or web server 3. So in this case, all three servers are healthy. So external load balancer will route the traffic based on the which server is free and which server doesn't have any traffic running on. So there are some scenarios like it routes the traffic based on FIFO condition, that is first in, first out. So based on the first in, it will transfer the traffic to web 1 and then web 2 and then web 3. Let's take a scenario where web server 2 is not healthy, like it went to down due to some reason. So it went to unhealthy status. So what load balancer will do? It will then route the traffic from web server 2 to web server 3 or web server 1. Now let's understand types of cloud load balancers. So there are two types of load balancers available in Google Cloud. One is application load balancer and another one is network load balancer. So application load balancer works at layer 7, which means they handle HTTP and HTTPS traffic. These are ideal for modern web apps where routing decisions are made based on things like URL, headers, or cookies. For example, you can send traffic for slash videos to one backend and slash images to another. That's smart routing at the application layer. And network load balancer, on the other hand, it works at layer 4, the transport layer. They deal with raw network traffic like TCP, UDP, and SSL, making them faster and ideal for systems that need low latency like gaming servers or VPN gateways. Unlike application load balancer, they don't inspect the content of request. They simply distribute packets efficiently across backend server. So now it's demo time. Okay, now we have completed our theory session where I have explained you what is load balancer, why it is needed, and how it works in backend. And I've explained you there are two main types of load balancer, that is application load balancer and network load balancer. So now we will see how we can create load balancer on Google Cloud. So first we'll start with application load balancer. So as you can see, I've already logged in to Google Cloud. So now we'll search for load balancer. Okay, so we'll click on load balancing, and I will first start with application load balancer, how we can create application load balancer and how it actually talks with traffic. So as I've clicked in load balancer, so you can click on create load balancer. So in this session, we'll be seeing how we can create application load balancer. And in the next session, I will also show you how to create network load balancer. So first we'll go with application load balancer, and it works on HTTP/HTTPS. So click on next. It should be public facing and based for global workloads. Global external application load balancer. Click on create load balancer part as a configure. Okay, give the name for load balancer. So maybe I'll give demo LB. And first we have to add the front end configuration where actually user will try to access your load balancer or access your site. So the name of the demo, let's say front end LB. Protocol should be HTTP. Keep everything as it is. Click on done. Next is backend configuration. So backend is like whenever user will try to access your web URL or the IP where it should route the traffic. So that's the backend service or backend. So click on backend service and click a backend service. So there are two options, either create a backend service or create a backend bucket. So in our case, we'll be creating a backend service. So click on create a backend service. Give a name, that's a demo backend LV. We'll keep description as it is. Backend type should be instance group, because in the backend we have created few VMs, and based on that we have created instance template and instance group, and we have added those couple of VMs into that instance group. So that is what we are using for our backend services. So we'll keep backend type as instance group, but if you want, you can select different options as well. So when you click on backend type, you can see there are multiple options: zonal network endpoint group, internal network endpoint, and serverless. So there are other options available. So we want to use instance group. We'll keep protocol HTTP and all the other things as it is. We have to create health check for an instance group. So I'll have to create a health check. So let's say demo health load balancer. I will keep port as TCP/80, logs to be off, and we'll click on create. And now we'll create the instance group. So as we already have an instance group created, that is load balancer backend group. So we'll just select the default one, port number 80, and everything else I'll keep it as default and click on create. Okay, what was the issue? So click on go to issue. Okay, so this name is saying it's already there. So maybe I'll click balancer one, will change the name to load balancer one and click on create. Okay, as you can see that the backend is created. I'll click on OK. So our backend service is created. Routing rule, I'll keep it as it is for now. But there are options where we can click on advanced, and based on the path set, you can do that. Like, so it is used, let's say you have different groups created, let's say for one for videos and one for images. So whenever user will try to access your website, and it will add as /image or videos, so it will route the traffic to a specific backend group. So I'll give you an example. Let's say your website it is, let's say this is the IP. So I'm just giving in default any IPs, and let's say you want to have route this traffic to image instance group. So when you click on image, so it will route the traffic to that particular instance group. As of now, there is nothing, so you will not see anything because we haven't created anything. So I'm just showing this to for a demo. And similar for this, you can for a videos. So it will route the traffic to specific instance group. So for now, like we're using the simple host. So for a traffic, it will route. So any for your site, it will route the traffic to a default instance group. So we'll keep this as it is, review and finalize. So we'll review what configuration we have added. So HTTP and the IP is ephemeral on works on port 80. So ephemeral means, let's say if your load balancer is deleted, so in that case, it will generate a new IP. And routing we kept as default, backend services as we have created, and we'll now everything's is fine. We'll click on create and we'll wait for load balancer to create. So yeah, it usually takes 2 to 3 minutes to load. So maybe I'll skip this part of this video, and once the load balancer is created, I'll move to that part. Okay, as now we can see that our load balancer is successfully created. So I'll click on. So here you can see the details. What is the IP and port and backend service detail and backend group. So now I will try to access our site using the load balancer IP to see if it is working or not. So we'll copy this. We'll work this on HTTP protocol. Click on continue to the site. So refresh couple of times. Maybe I'll try to restore it. So it's not loading. We'll see, and we'll try to find out what is the cause. So maybe check here. It should be working on port 80. IP is right. 3454 188.50. IP is correct. So why I'm getting 404? We'll try again. Okay. So generally it takes a minute or two to actually work. So as you can see that now we can see the output. So it's like page served from this load balancer backend group. So if we can refresh, it will show you different group name as well. As you can see, it's now PLZ2. So we have created a couple of instance group where actually the traffic is going. So let's say if there is a traffic on one instance group, it will route the traffic on another group. So this is all done by your load balancer. You don't have to do anything manually here. So you can refresh a couple of more times so you can see this is changing. So this is all about how we can create application load balancer and how your traffic will be routed to the load using the load balancers. Okay, now we can move to our network load balancer, and I will show you how we can create the network load balancer and how the traffic will be working on network load balancers. Okay, now we can look how we can create the network load balancers. So we'll search for load balancing. Click on create load balancer. So this time we will select network load balancer. Click on next. Here we'll use pass-through load balancer, not the proxy load balancer. Use it as public facing external and click on config. Give the name. So maybe I'll give demo network load balancer. So yeah, first we'll need to select the region here. So we'll select US East 1. I will create the health check. And else other things will keep at it as it is. Click on create. In the backend, we'll select the backend. So we have two backend groups. So we'll select the first one. Else other things will keep as it is. Click on front end config. Create new front end. So I'll give demo front end network load balancer. Okay, and this time we'll select the IP address from ephemeral to static hood. So we'll create the static IP. So as already we have one static IP created, so we'll use that. Or if you want to know like how I have created it, so I'll create one more, create IP address. I'll give the name demo network static IP. So static IP means as even if your load balancer is deleted, that IP will remain as it is and the IP will not change. So okay, it's selected that and we'll add the port number 80 as a port number. Click on done. Okay, review and finalize. See, everything is as expected we have selected. Click on create. So yeah, as you know, it usually takes a couple of minutes to create the load balancer. So maybe I'll skip this session, skip this, and once the load balancer is created, I'll move to that session. Okay, now we can see that our network load balancer is created and backend is also showing healthy. So we'll click on the load balancer and check the details such as IP, as this is a static IP which we have provided. It is in healthy status. So now we'll try to access the website using this IP. Use HTTP protocol. Okay, now we can see that page is serving from this particular VM. We'll refresh and see if it is switching to another instance or not. Okay, it is not. Maybe there is no traffic on this, so it's not switching to another. Maybe I'll try to open one more incognito mode to see if it is switching to another or not. Okay, we'll see. Yeah, as you can see, this page is served from 28M4 instance, and this is getting served from 34 CB. So now I think you understand like how we can create the network load balancer and serve your traffic on network load balancer. Okay, now we have completed our hands-on labs on application and network load balancer. So I'll just wrap up with what we have created. So we have created two load balancer. One was application load balancer and another one was network load balancer. So application load balancer, it works on layer 7, which supports HTTP and HTTPS protocol. And also it supports routing, path-based routing. It supports path-based routing. In the other hand, network load balancer, it works on layer 4, which supports TCP and UDP protocol. And it doesn't have any path-based routing.